Okay, moving along with the HackerRank arrays stuff. We've got New Year Chaos. Determine how many bribes took place to get a queue into its current state. Seems kind of juicy. It's New Year's Day and people are in line for the Wonderland roller coaster ride. Each person wears a sticker indicating their initial position in the queue from one end. Any person can bribe the person directly in front of them to swap positions, but they still wear their original sticker. One person can bribe at most two others. Determine the minimum number of bribes that took place to get to a given queue order. Print the number of bribes, or if anyone has bribed more than two people, print two chaotic. Interesting. Bribed more than one person can bribe at most two. If anyone has bribed more than two people. Interesting. Okay. If person 5 bribes person 4, the queue will look like this. Okay. Only one bribe is required. Print 1. Okay. Person 4 had to bribe 3 people to get to the current position. Print 2 chaotic. Okay, well, one easy way I think to go through this is just to look through each index, and then depending on what number is in the index spot, you can take the delta and determine how many people were bribed to get to the location. So that'd be, I guess you could add one onto the index. So instead of 0, this would be, we could call it index 1 if we index from 1. 1, 2, 3, 4. This is different. The delta is 1, so that he bribed one person. This would be 1. The delta is 3, so he bribed 3 people. I think that's how you would do it. So if that ever happens, you print 2 chaotic. Otherwise, you sum it up and then print at the end. All right. I mean, this is really dependent on the index. I mean, I think you would have to go through everything until everything but the last. Because if you got to the second of the last, you either knew if the guy bribed him because there's a delta, or they didn't bribe him, in which case they're at the end. How many? It's up to 10 to the 5th. That's a lot. Oh no. Second line is. This is how many people are in the queue. The second line has n space separated integers. So the first line is how many people are in the queue, so up to 10, but the second line is n space separated integers describing the final state. Oh, it's the number of test cases. Okay, yeah, whatever. Yeah, I don't think this would be wildly difficult. Do I have to print it out? Yeah, I print it. 5 went 3, so that's why it's too chaotic. Okay, so I just print it. Yeah, whatever. All right. So we'll iterate through the queue and then find the delta. I need to enumerate queue for index lm. I believe that's how you do that. The difference is going to be let's see, is bribe. And then we'll do the difference between the element and the index. And then if is bribe is greater than 0, that means there was a bribe. Yeah, I'll just stick with delta. I think that's a little more, that's what it really is. And then here we need to take we need to keep track of the amount of bribes that were done. So if delta, then bribes plus equal delta if delta is greater than 2. We're going to print it's going to be single to chaotic and then return. So we're done with the entire function once that happens. Otherwise we sum it all up, and then at the very end we want to print bribes. Oh, my delta was, I'm doing this incorrectly. So the element, it needs to be diffed with the index plus 1 because we want to index from 1. I said it, I didn't code it. And there we go. Oh, this one didn't work. 7. Okay. 1, 2, 3, 4. So that one wouldn't count. Yeah. 5. It's another 2. 6. 7, 8. Oh, I got this all sorts of messed up. 4 ended up at the very back. So 3 would have had to bribe 4. No. 5 bribed 4 and 3. 7 bribed. Oh, would it change everything as you go? Oh, I might have oversimplified this. So 5 would have bribed, yeah, 4 and 3. Then 6 would have had to bribe 4. Then 7 would have had to bribe 4 and 6. 8 would have had to bribe 4 and 6. And that would give, okay, and that would do it. So I guess you also have to keep order of what the array looks like as the bribes are made, because that will change how it all goes down, I guess. Yeah, I grossly oversimplified this. I wonder how many would actually pass, though, out of curiosity. Oh, only those first. Okay. Yeah, go ahead and run that again. Interesting. Okay, so let's see. Maybe you need to look at where they are and then look at how many numbers that are less than them are behind them. Would that do it? So if you looked at 5, 3 and 4 are behind it. That's 2. 3, nothing underneath it. Nothing less than it is behind it. 7, you have 4 and 6 behind it. 8, you have 6 behind it, and 4 behind it. And then 6, you have 4 behind it. I guess that would make more sense because you could only bribe the things in front of you, which means that they would have had to either. But that would be. That would probably take a lot more computing time if you had to look at everything behind you. But I guess didn't they say that it was only 10, only a max of 10? Yeah. No, no, no. And is okay. This is how many test cases. So up to 10 test cases, and then I don't know what's 10 to the fifth is like 10,000. Is that right? 100,000. Yeah, 100,000. So yeah, if you did big O of n squared, that'd be pretty big. I've been actually taking breaks in between pausing and unpausing the recording. So sorry if my thoughts seem like they're jumping around a little bit. They probably are. One thing I stepped away for a little bit, trying to clear my brain for a second. One thing I'm thinking of now, one way to maybe go about doing it is we know that we should be seeing, going back to that whole idea of what we have and haven't seen, we know we should be seeing a 3 and a 4 in between this 5. And until we see those, we know that every number that isn't one of those numbers that we're supposed to be seeing has been skipped. So if so, I'll try to walk through what I'm thinking. If we have maybe a set that is missing numbers, so we have 1, we're supposed to see 1. We have 2, we're supposed to see 2, and we can figure that out by the delta. And then we get to 5, and we have 5, but we're supposed to have 3. So if we do the range of index to LM, or the 5, so we would have 3 and 4 in there, and we would add those to our set. And then we know that we're missing 2, so the amount or the length of that set of those missing numbers, that's how many 5 is jumped. So we know that 5 is, or bribed, I guess. 5 is bribed 2. Then we get to 3. Well, 3 is in the set, so we'll take that out of the set. And now we're at 7, so the next element is 7. And the range between 3 and 7 is 3, 4, 5, and 6, but we've already visited 3 and 5, so we'll also have to keep track of visited. So let's do missing numbers is a set, and then we'll have visited is a set, and then the 3, 4, and 5, 3, 4, 5, and 6. Visited has 2 of those, so that means we're missing 2 numbers still, which are 4 and 6. So we'd add those in. We're missing 2 at the time that we're moving to the next element, so we're going to have to add 2 bribes in. So now we're up to 4. Then we have 8, and 8 is in the spot of 5, 6. It's index 6 since we're indexing from 1. And the range between 5 and 8, we have 5, 6. Sorry. Yeah, 5, 6, 7. 5 has already been visited, 7 has already been visited, so 6, we would add that to the visited set, but since it's already there, it's not going to add anything. Then we take the length of what's missing. It'd still be 4 and 6. So that would be another 2. So that would bring us up to 6, and then we get to 6. The difference between, or the range between this index and 6. So I guess you would only check if it's positive. And this index is 7 and the number is 6, so the delta would be 0. So we wouldn't consider this one. Since it's 6, we would take it off of the visited set, and then the length of missing number set is now only 1, because 4 is the only missing one. So we know that 6 is bribed 4, and that would get us to our expected output of 7. Then 4, we'd take it off of the visited set, or take it off of the missing numbers set. Missing numbers is now 0. So I think that might be a decent way to go about doing this. I don't think I want this absolute value stuff, because I only want to look at places where the number is greater than where it's supposed to be, because that means that there was a bribe that happened to get it there. And then I still want to check the missing numbers, and yeah, so we want to check this if element is in visited. Let's see. Python set remove. I'm guessing it can handle a remove if removes it from the set. Doesn't return a value. A key error will be thrown if it is tried to remove. Okay, so we'll just leave that here. We'll remove it if it's there. Or, oops, missing numbers. And we will always add it. Oops. We will always add it to visited. And now if the delta is greater than 0, if it's what's 7 at? 7 would be at 5. Yeah, I think that's okay. This might be a problem later on. I might have to check against the length of missing numbers, but that's alright. So how would I find the range? I need to somehow find the range of all this stuff. And that would help me find my missing numbers. So, guessing, let's do Python set add. Is it just one element? Okay, so I can't add. Okay. So I'll have to go through the I have to go through the range and add in each one as I go through it. So okay, that's my delta, and then I will need to, if there is a difference, then I need to find the range for I don't know, I in range of index plus 1 and the current element. So that'll be our difference. We'll add missing numbers. We'll add I. Yes, I'll make that J just because I feel like we've already used an I with index. So this adds in the numbers that we expected to see. I might need to do an in just to see if it exists. It's like has. Okay. Is it just in? That's what the. Okay. Yeah. If J not in visited, then we'll add it. This one, yeah. Then the amount of bribes is going to turn into missing numbers dot length. Just use len. Okay. Numbers. When do I take it out of? There we go. Okay. Ooh. That's not good. Well, I guess that'll happen, won't it? How did I not? I don't know how I didn't get that index error before. Okay, let's do just delta equals 0, and then we'll do a try except around this, and it's an index error. And if it's an index error, we just let it go, and it'll move along. Okay, so it only worked for one. Interesting. Which is the one that didn't work before, but then it stopped working for the ones that did work before. Okay. Interesting. So in this case, I want to know how all this works. So I want, I'm going to print a lot of things here. I want to print the element. We'll do index element print visited. We want to print missing numbers and bribes. Okay. So we have the first one. We have index 0, element 2, bribes 1. Okay. That's right. Index 1, element 1, bribes is still 1 because it's visited. Visited 1 and 2, we have nothing in this one. Index 2, element 5. So we're missing a 3 and a 4. We visited these. So bribes would be 3. Yep, okay, that's fair. So this wouldn't work because the element, yeah, okay. So I guess it only matters if the element that we're currently looking at is greater than the largest element we haven't visited. Because if it's smaller than it, then that means it hasn't bribed it. If it's larger than it, that means that it has been bribed. Right? What if it was switched and it was 4, 3? Then we'd see 4. 4 is not greater than the largest element, which is 4. 3 is not greater than the largest. Okay. So we would also need, we'll also keep track of max missing number. For adding in new numbers, let's add this max missing number iteratable. So we want the max missing number and oops, missing numbers. So recalculate the missing number whenever missing numbers are added in. Oh, it still didn't solve it because we only want to, so we only want to add bribes if the element is greater than, so if lm is greater than our max missing number, then we add it in. Otherwise we don't. Okay. So we have element 2, visited them. 5, we skipped 2, which means bribe should kick up. 2, 4, Well, 3 is less than 4, so what if there were 3 of them though? What if um, there's a 6, 7, 8 after this, and it went 3, 5, 4. 3 is less than the max of 5, so it would not receive any bribes. We wouldn't count bribes for it. Then we have 5 is less than. No, it's not. It is greater than or equal to the max missing number. Because if it is the max missing number, we only do this because this is the only place we add in missing numbers. We wouldn't do it out here. So I think that's still fine. We'd always find the max missing number. And oh no, because we could remove them. So yeah, this would uh-oh. What did I miss? Indent. Oh, okay. Surely a set is iteratable. No? Okay. Let's take the prints out. See what that looks like. We're still where we were. So this one passes, which is what I would have been looking at to try to get it right. Sample test case 1 doesn't want to work. 1, 2, 3, 70. Okay, this is what I was looking at before. So let's bring these back in, and then I want to watch sample test case 1. Yeah, this one. Index 1, element 1, bribe 0, index 2, element 2, bribe 0, index 3, element 5, bribes 2, index 4, element 3, bribes 2. Yep, there are no extra bribes. There shouldn't be. Where's 6? It's index plus 1 to the element. So element is 7. Index plus 1 would be 6 to 7. Oh no, it'd be 5 to 7. It would be, if not in visited, and it's definitely not in visited. So why didn't 6 get added to the missing numbers? But it did here. That doesn't make much sense to me, because the range should be index plus 1 and then element, and that's what's printed here. So that should be range 5 to 7, which is 5 and 6, and 6 isn't in the missing numbers, but it gets picked up in this one. Yeah, I don't know why it's not added. Sure, I mean, let's just, I gotta know why it's not added. Didn't print anything, right? Because it would go, there's nothing in there, it's blank set, there's nothing there, blank set, and then index 3, element 5, it finds 3 and 4. index 4, element 3 doesn't find anything. That's fair. I don't even think that's a range. And then index 5 to 7, it doesn't find anything either. But then element 6 to range 6 to 8, it finds 6 and 7. Yeah, I'm confused by that. Oh, it's because the delta is not greater than 0. Oh. How did that happen? Yeah, because it's not ever even called. So that means that it didn't find that the delta was greater than 0. Does the delta even matter? Let's think about that. Does the delta even matter? I don't think the delta matters. Let's wrap this in a try catch. So we, okay, so we don't need the delta. At least that's not what it looks like. Passes all of them. Oh. Alright, well, I'm not going to lie. I didn't really expect that to happen. Okay. Let's go over that and make sure I understand that. So I'm not just throwing something into the wind. It all had to do with the missing numbers. That was pretty much everything. So you needed to loop through all of them, and then if the element was missing, you remove it, and you, no matter what, you always add it to the visited, because you visit every number that you hit. So that makes sense. And then you take the difference between where you are, which pretty much means what should be there and what is there, and you add those numbers to the missing numbers if they haven't already been visited. And however many missing numbers there are is equal to the amount of bribes that, oh shoot, the amount of bribes that had to have been done. Alright? Yeah. And if there are ever more than 2 bribes at a time, that means it's too chaotic. Also, if the element is greater than or equal to the missing number, we add it to the bribes. Otherwise, it doesn't count as a bribe because there could still be missing numbers, but if it's a number that's less than the max missing number, that means that it didn't bribe anything. Okay, I guess that makes sense. I mean, it made sense in my head when I was going through it, obviously, but I I didn't think it would match all the test cases up like that. So that's kind of nice to see. Um, all right, well, that was New Year chaos, and that was pretty chaotic for me. Uh, got my 40 points, and I guess I'll see you in the next one. Thanks for watching.